Martina. Thanks for joining me for Espresso 4.0 again. Your pregnancy seems to be going very well. Yeah. Cheers to that. I want to talk to you about continuous casting process. Continuous casting process is one of the key processes within the steel manufacturing industry. How does the continuous casting process look in Industry 4.0? What are the benefits that it can look forward to in terms of optimizing the production?
Yeah, so as you mentioned, continuous casting is a key to the process of producing steel. It can also be a bottleneck, actually. Mm-hmm. So there are several, let's call them opportunities, or several points that could be optimized through advanced analytics. For example, we have predictive maintenance on specific equipment, like, for example, the cutting torches. We can have predictive quality. It depends how the machine is cutting. I don't know if we're talking about slabs, billets, And also there is the energy, let's say, domain. Optimization of energy could also be done through advanced analytics, ML, and everything that falls into the digitalization and innovation umbrella.
Gotcha. Speaking of predictive maintenance, it's one of the buzzwords within Industry 4.0. But can you bring the idea a little bit closer to us in more specific examples relating to the continuous casting, of course?
Yeah. So if we take into consideration predictive maintenance, there are some opportunities, like, for example, avoid stoppages, or downtime, avoid failures, being able to plan maintenance efficiently, so not to have, sudden stoppage, where everybody is rushing to take an action, but actually being able to plan something in advance efficiently without actually impacting production as least as possible. Of course, continuous casting, as you mentioned, is part of a bigger process. We have the blast furnace or the electric arc furnace before, and then everything that comes after casting. So casting could also be a bottleneck. If we stop casting, then most likely we also have to stop the furnace. So, it's not just a limited issue or a limited problem. It's actually something that could extend further and generate cost, generate losses in output, and
Understood. And how would let's put it in a day-to-day terms? Say a process engineer in a steel manufacturing company, right, in a steel mill, was responsible for the continuous casting process. How does his day-to-day look like in a smart factory? What are the tools that they're using to help optimize the process, and how those tools help them?
Mm-hmm. So there are multiple ways that either engineers or operators as well, because at the end of the day, it's actually the operator who is checking the real-time data. Absolutely. And what is actually happening on the continuous casting. So yeah, for example, the advanced analytics could provide some alerts for specific deviations, or a recommendation to take specific actions. Like, for example, if we take the cutting torches, maybe there is a small equipment like the potentiometer that needs to be replaced. So it's degrading little by little, and the intelligence, the logic, whatever we want to call it, could actually give indication of this time to failure or degradation status of the equipment. Or another aspect could be, for example, when the equipment needs to be cleaned, for example, or lubricated. This is also another aspect that the intelligence could recommend or could highlight to the operator when the time is due. So these are just some of the example that could be integrated into the continuous casting to optimize the process.
Understood. It looks like from what you're saying is not just one type of stakeholder that's involved or is benefiting from this. We have the operator, right, that's getting real-time or close to real-time recommendations.
Yes.
We have a process engineer who is planning and having a bigger picture
Analyzing,
of exactly.
Yeah. Mm-hmm.
We have the maintenance, head of maintenance, and the maintenance team who knows exactly how and when to approach the maintenance issues before they happen, measuring micro events that will lead to bigger failure. And on top of all of that, we have a head of the plant who is obviously saving on the costs and by optimizing this production in terms of predictive maintenance and other examples.
Yeah, and also, for example, a warehouse could also be part of this big schema that you were talking about, like planning and order the parts to be substituted on the line. Just to mention another one. Of course, also IT is another big stakeholders, especially at the beginning when we want to start a project. IT has to grant access to the data, to the infrastructure, define the infrastructure or define the requirements based on the internal policy or internal security procedure.
Okay.
So there are several, as you said, there are several sides or stakeholders that needs to be involved.
I'm glad you mentioned the IT because, say, I am a steel mill and I want my continuous casting process to be digitalized, right? I want to use some of the tools that help optimize it through leveraging of the data, using machine learning, AI, you name it. Where do I start? How do I go about it?
So yeah, the first step would be to discuss with the IT stakeholders to define what are their requirements, based, of course, on their internal policy, procedure, cloud, not cloud, hybrid approach through the edge. So
address cybersecurity concerns.
Exactly, all these things, all these factors. And actually, once this is the biggest part to discuss and define. Once we have a definition of what we want to create together, then we just need to put it in place. We just need to, in practical terms, to generate the connection, whether it's through OPC UA or another protocol. So, but the key point is really to define what we want to achieve and how we want to achieve, what kind of infrastructure we want to set up. Something that is not a burden, something that it's an open architecture that can be reused in the future, where other parts could be added with simplicity, not a closed ecosystem, but something actually flexible that actually facilitate the integration of these new technologies rather than becoming a burden and something super complex.
Okay. That's the first step. Now, let's say we've done the architecture, we've connected, we're consuming the data. We've even created the necessary algorithms that help us process all the parameters and created a predictive maintenance model.
Yeah.
We have people working in the factory that have been with the factory 10 plus years. Okay. Yeah. They have experience. They've dealt with these assets from what they know and experience, sometimes even intuition. How do they move from something they know if it's worked 80% of the time to something that we're claiming works 90 or plus percent of the time? That's data. It's a program, something coming up on their screen that sometimes might not even intuitively make sense to them.
Yeah. So of course, this change is gradually made. So we don't go from 0 to 100 in 1 day or 3 days, but it's a change. So everything that the intelligence does, or everything that we develop together, will be evaluated by the business experts. So first of all, it has to make sense from a business point of view. The results need to, to actually bring not only an ROI, which of course the very first thing that everybody is interested in, but also it has to make sense for the daily work. It has to ease the daily routine, the daily work of the people in the plant. And so, yeah, this everything goes under an evaluation, test and trial. And of course, there can be also sometimes false positive, for example. So in order, once, let's say, we develop the intelligence is deployed in operation in real time. The models, this intelligence will for sure need to be fine-tuned. So we will go through maybe a period where we have some false positive, but with the help, with the support of the business and of the data, let's say data people or data experts, the models is fine-tuned, and then until it doesn't generate any false positive, and it totally makes sense, and it totally integrates with the daily routine of the people, the operators or engineers.
Okay. Now that you mentioned, excuse me, now that you've mentioned it, one of the concerns that was raised by a steel manufacturer that I had the pleasure to speak to recently was that their business experts that are necessary to be part of this creation of this ecosystem are not available simply to be on these kinds of projects, to think of business cases. They have their job to do and so on and so forth. How important instead is it that they do dedicate some time to the creation of these types of models for the continuation of their work to remain competitive on the market for the company as a whole?
Yeah. So I think your question includes actually 2 points. The first one is the fact that these people somehow will need to adapt. This change is going to happen whether they want it or not. And so they need to adapt to this new environment, to this new system where human check go alongside with automation or with data analytics control. On the other side, I think the other, let's say, hidden question was how much time they should dedicate to this. Let's say we want to start a project. Okay, we define the project, we define the target, we have a roadmap, different milestones, different phases. I'd say, of course, the beginning, more time will be required, maybe 1 day of kickoff, depending always on the complexity of the project. But in general terms, we can say that kickoff could take 1-2 days with all the stakeholders involved. And then you can maybe consider 3-4 hours per week by a project management on the plant side. And he should be the point of contact, the point of reference, to talk to the various stakeholders, to collect the missing information, maybe, I don't know, check that we have all the data that are necessary, the normal project manager or point of contact.
Okay.
And of course, these 3-4 hours, maybe 2, at some point when the project, has started, will be useful to make sure that all the expectations are met and all the communication is flowing smoothly among the parts.
To that end, going off that sort of, the feeling I got, in fact, is that there is a certain part of the market that has a perception that they are out looking for ready-to-use solutions, just plug and play, and it does everything, as opposed to custom making something. How realistic is that? And is there a benefit to one or the other approach? Does something like that exist?
Okay, well, as you mentioned, there are these two approaches. I would say by our own experience, they both worked, but depending on the issue. If you have a very complex issues, like you want to automate a furnace or something like that, I don't think you can expect something that is a ready plug and play, because every machine, every furnace might be from a different generation, might collect different kind of data, different frequency of data. So there's always involved kind of a customization and tailoring. But there are also algorithms that are ready to use, like, for example, anomaly detection for predictive maintenance, as we want to call it, that are actually autonomous. You basically connect the data or import the historical data, and the algorithm will basically transform and handle this data to give you a meaningful output. So it depends a bit on the complexity and on the problem that you want to tackle. Okay,
perfect. Gotcha. Thank you, Martina. This was very enlightening. I think this would be useful for a lot of people within the steel manufacturing industry. And if they have any questions or want to add anything, they're welcome to join us in Espresso 4.0. Maybe sit there or at least be on the other side of the screen, whichever the case.
Yes. Thank you very much, Philip. And I thanks also our audience to listen to me.
Ciao.
Ciao.